In today's video, we will take a look at two very important inequalities in mathematics, the triangle inequality and the reverse triangle inequality. These inequalities show up everywhere in mathematics, especially in more advanced courses like real analysis and complex analysis, where they're used to find upper and lower bounds on various things such as sequences of numbers or a series or various functions. And so it's useful to keep these in mind. Let's begin by covering the triangle inequality. The triangle inequality states that for any two real numbers, x and y, we have the following relationship. The absolute value of x plus y is less than or equal to the absolute value of x plus the absolute value of y. To prove this result, we will begin by doing a little bit of rough work or scratch work on the side, and then we will write out the full formal proof. Okay, now taking a look at our scratch work, the first step will be to somehow get rid of these absolute values because absolute values are a little bit hard to work with. And one thing we can do is square both sides of the inequality. And this is perfectly fine to do because both sides are non-negative. Once we do this, the left hand side over here, we can just drop the absolute value because it's redundant. When we square it, it's still going to be non-negative. And on the right hand side, we can expand out using the FOIL method to get this. And now in the next step, we will once again on the left hand side just expand using the FOIL method, and on the right hand side we will repeat some of the same steps. The absolute value over here is redundant because we're squaring, and same thing over here. We can drop the absolute value on the y because we're squaring, so it's redundant. And in the middle we have the product of two absolute values. That can be written as just the product of a single absolute value. It's just one of the properties of absolute values. And lastly, we can cancel some common terms on both sides. So x squared can go, the y squared can go. We can also divide by a factor of 2, and we get something like this. And now we can stop right here because this statement is something that is obviously true. And it might not seem like it at first, but really there's a property of absolute values that says that for any real number a is less than or equal to the absolute value of a, right? So if you were to take x times y is just some number, call it a, right? So a is less than or equal to the absolute value of a. It's just one of the properties of absolute value, right? Because if a happens to be a non-negative, then it's equal to its absolute value. Whereas if a happens to be negative, then it's strictly less than the absolute value of a. In the formal proof, we're just going to reverse these steps and also write it out in nice sentences. Okay, so now let's take a look at the proof. It's basically what I just said, but written nicely in words. And so we begin by saying, for any real number, we have that a is less than or equal to the absolute value of a. Hence, for any two numbers, x and y, we must also have that x times y is less than or equal to the absolute value of x times y. And again, if you're having some trouble seeing how we're applying this property, you just want to think that x times y is just some number, right? X times y is just some number, call it a. Then a is less than or equal to the absolute value of a. Okay, and now we just reverse the steps. So we start from the bottom where x times y is less than or equal to the absolute value of x times y. And we multiply both sides by 2, and we add in the x squared and the y squared, and we get this statement. And we just work our way backwards. But I hope you see that if we didn't do the scratch work, then it would be very difficult to come up with this proof. It would be somewhat out of the blue to multiply both sides by 2 or add in an x squared term. And how would we know to pick up redundant absolute value bars, right? How we came up with this is with our scratch work. So that's why whenever you're doing a proof, you want to do some sort of exploration on the side and manipulate the identity that you're working with. And then in the proof, you write it out nicely, and that's why the proof, sometimes it looks like the answer came out of nowhere. This is exactly these steps above, just reversed in the other order, and at the end, we end up proving the triangle inequality. Now let's take a look at the reverse triangle inequality. The reverse triangle inequality states that for any two real numbers, x and y, we have the following relationship. Now this relationship looks a little bit more complicated than the previous inequality, but it's not too bad. So what we have here is a couple of nested absolute values, and so it states that the absolute value of the difference of absolute values of x and y is less than or equal to the absolute value of x minus y. And sometimes you might see this right hand side written as the absolute value of x plus y instead of a minus sign. So if you see that, just know it's somewhat equivalent, because since this result holds for any two numbers x and y, I can just replace y with a minus y, right? So what we get is x minus y, that gives us the x plus y. And so when I plug in minus y here, the absolute value will just absorb the minus sign, and so this side doesn't change, right? So really, you can have this as the absolute value of x minus y, or you could have this as the absolute value of x plus y, and it will still be bigger than or equal to the left hand side. Now the reason why you might see it with the x plus y is because the triangle inequality gave us the right hand side of this relationship. The absolute value of x plus y is less than or equal to the absolute value of x plus the absolute value of y. And now the reverse triangle inequality gives us a lower bound. And so again, like I mentioned at the beginning of the video, this is very useful for finding upper bounds and lower bounds on various mathematical objects. So now let's take a look at a proof for the reverse triangle inequality. I really like this proof because it actually follows from the triangle inequality via some substitutions. So before we get started with that, we need to understand what we need to prove, right? In order to prove this inequality, we actually have to show two things. So we need to show that the absolute value of x minus y, which is this number, it must be bigger than or equal to the absolute value of x minus the absolute value of y, and it should also be bigger than or equal to the negative of this number, because if the absolute value of x minus the absolute value of y is bigger than or equal to this number and it's negative, then we can say that it's bigger than or equal to the absolute value of that number. And so that's what I've written here. We must show these two statements. This number, the absolute value of x minus y, should be bigger than or equal to this number, and it's negative. Now if you're having some difficulties following that, that's okay. We can also use one of the properties of absolute value that says that the absolute value of a is less than or equal to b if and only if a is between negative b and b, right? So in this case, the relationship it looks a little bit more complicated because there's so many absolute values, but you really want to take the absolute value of x minus y, this entire thing, to be your b, and you want to take a to be the inside portion here, the absolute value of x minus the absolute value of y. That's your a. And so if we just apply this rule, what we're trying to show is two things. We're trying to show that a, which is the absolute value of x minus the absolute value of y, is less than or equal to b and bigger than or equal to minus b. And that's just another rephrasing of what I've written over here. So now let's see how we can show the first one. So we begin by writing the absolute value of x. And then what we'll do is we'll add 0 in a clever way. And again, this is going to be a common trick that appears in many places in mathematics. And the 0 that we add here is a minus y and a plus y. Okay, and you'll see why we do this in a little bit. So absolute value of x is just equal to the absolute value of x minus y plus y. Okay, and then I'll group the x minus y together as one term, right? And I'll think of this y as a separate term. And then we can apply the triangle inequality above to say that this is less than or equal to the absolute value of x minus y plus the absolute value of y, right? Just think of this as one number and think of this as the other number. Then it should be less than or equal to the sum of the individual absolute values. And then we can simply subtract the absolute value of y on both sides, and then we are left with this, which is exactly statement 1. And now you might question, okay, how come you did minus y plus y and not maybe plus y minus y, right? Because it's also a perfectly valid way of adding 0. Now we could have done that, right? And we would have still ended up with the absolute value of y, but over here we would have had x plus y instead of x minus y. And so yeah, there is a little bit of trial and error involved, and you just have to understand what you're trying to show, and you'll get better with practice. Now let's show the second statement, and we will do something similar. We'll start off with the absolute value of y, and then what we're going to do is add in a clever 0. So this time let's subtract x and add x, and then let's think of y minus x as one number and then x as another number, right? And then we will apply the triangle inequality here to say that this is less than or equal to the absolute value of y minus x plus the absolute value of x. And now we can subtract x on both sides and we'll get this result. Now this isn't quite exactly what we're after, but we have to do one more step. So what we can do is actually flip the order of these two so that we have the absolute value of minus x plus the absolute value of y, and then we'll factor a minus sign from that, and that gives us this side. And over here I can do the same thing. I can reverse the order of these two guys to get minus x plus y and factor a minus sign. So that would give us x minus y in brackets with a minus sign up front, but the absolute value just absorbs that. And this is exactly statement 2. And so there we go. That proves the reverse triangle inequality. In this video we covered the proofs of the triangle inequality and the reverse triangle inequality. If you found this video helpful, I would really appreciate it if you could leave a like down below. I would encourage you to subscribe for more math videos, and if you have any questions or comments, please feel free to leave them down below. I would be happy to respond.